Today, we're diving into something that sounds, well, completely impossible. We're talking about a propulsion system, a machine that claims it can move itself through the total vacuum of space without pushing off of anything. It sounds like it breaks the laws of physics, so let's dig in and see how it supposedly works.
Right up front, the author of our source material, Michael Lewis, makes one thing absolutely crystal clear. The laws of physics are not suggestions. You have the laws of conservation of momentum and energy, and you just cannot break them. It's impossible. So if any idea or machine seems to violate these rules, it's dead on arrival. And that brings us to the central puzzle, doesn't it? If those rules are unbreakable, how could any machine, a completely self-contained system, generate forward thrust? It sounds like trying to lift yourself up by pulling on your own shoelaces. It just shouldn't work.
Well, this is where it gets really interesting. A theory called closed-loop pulse propulsion, or CLPP for short, makes a pretty bold claim. Its inventors argue that they aren't breaking the laws of physics at all. Instead, they say they've found a loophole, a really clever and, highly controversial way to work within the rules.
Okay, so to even begin to understand how CLPP could possibly work, we've got to do a quick refresher on those fundamental rules of the road that it absolutely has to follow. No exceptions.
It really boils down to two simple, inescapable truths. One, energy can't be created or destroyed. You can only change its form. And two, for momentum, every single action has an equal and opposite reaction. You can't get something for nothing. These two laws are basically the universe's unblinking accountants.
So keeping those rules in mind, how do we normally get around, especially in space, where there's literally nothing to push against? Our source material has this fantastic analogy. Just picture yourself floating in space with a shotgun. You fire it, the slug goes flying one way, and that explosion creates an equal and opposite reaction that sends you flying backward. That recoil, that is conventional thrust. Rockets are basically just doing the same thing, but firing a constant stream of tiny gas particles out the back. And that, right there, highlights the huge difference. A rocket works by constantly throwing mass away, its fuel. Eventually, it's going to run out. But the radical claim of CLPP is that it can generate thrust by just recycling mass inside the system over and over again, which means, in theory, it could just keep pushing itself forever. So how is that even possible? If you can't throw anything out the back, where on earth does the push come from? Well, the theory proposes a really clever workaround. It's all about converting one type of motion into another. First, you've got your basic linear momentum. This is the stuff we're all familiar with. It's force moving in a straight line. A cannonball flying through the air, a rocket pushing forward, that's all linear momentum. But then you have something else, angular momentum. This is the energy of rotation, of spin. And unlike linear momentum, which actually moves an object from point A to point B, angular momentum can store a massive amount of energy, while the object itself pretty much stays in one place. The perfect example is a spinning ice skater. We've all seen this. She's spinning with her arms out, and then she pulls them in tight, and whoosh, she suddenly spins way, way faster. She didn't get a push from anywhere. All she did was convert the momentum from her outstretched arms into pure rotational speed. She transformed momentum, all within her own closed system. So, how does CLLP try to use this ice skater principle to move a spaceship? Well, it all comes down to a proposed three-step cycle, a kind of mechanical dance. So the CLPP cycle is basically a three-part process. It starts with an internal push, then it converts that motion into spin to kind of bank or store it, and then it unleashes that stored energy as a second, much stronger push. Let's walk through that step by step. Okay, step one, the initial thrust. Imagine there's a railgun inside a spaceship, and it fires a heavy slug towards the front of the ship. Because of that equal and opposite reaction rule, the slug shoots forward and the entire ship recoils and starts moving backward. At that exact moment, you have two separate systems moving in opposite directions. The ship is officially moving. Now for the trick. This is the clever and, to be honest, the most controversial part. Instead of letting that slug just slam into the front wall, a special tether system catches it. This system perfectly converts the slug's straight-line motion into pure spin, storing all its energy like a flywheel. Now here's the crucial claim. The theory says that this act of converting linear motion to spin has zero effect on the ship's backward motion. It just keeps on drifting. And finally, step 3, the recombine, or the second thrust. The tether releases the spinning slug. instantly converting all that stored rotational energy back into linear momentum. The theory claims that because of the physics of it all, this release gives the slug a much higher speed than it had from the initial railgun shot. This now high-speed slug slams into the ship, giving it a powerful forward push that adds to its overall velocity. If that sounds a little mind-bending, the source uses a great real-world example: a yo-yo. Think about it. Gravity pulls the yo-yo down in a straight line. That's linear motion. But at the bottom of the string, it's spinning like crazy, storing all that angular momentum. Then, with just a tiny flick of your wrist, you convert that stored spin back into linear force, and it has enough power to climb all the way back up the string, fighting gravity the whole way.
So after that three-step dance of thrust, spin, and then thrust again, what does this all add up to? Let's just recap the truly radical claims being made here.
So, to put it all together, the CLPP theory is saying that a machine can actually achieve net propulsion in a completely closed loop. It doesn't expel any fuel, and each pulse of this cycle stacks on the last one, continuously adding velocity. The creators insist this works within the laws of conservation because it's just cleverly converting momentum between its linear and angular forms. It's basically trying to push off of itself. So is this a genuine loophole in the laws of physics? You know, a revolution that could change space travel forever? Or is it just a brilliant but ultimately flawed thought experiment? For now, it remains a totally fascinating puzzle that really challenges our most basic ideas about how things move.